Welcome everyone to your last chemistry homework of the year. Woohoo! Today we're going to be combining what you know about gram molar mass, which you did in the last homework, and the mole unit, right? 6.02 times 10 to the 23rd. You'll definitely need a calculator for this one, so I put a link to your calculator that you can use right here. All right, this is the calculator that we can use instead of, or you can use your personal one, that's fine. So now that you know how much 1 mole weighs, what if you don't have exactly 1 mole? For example, if we know that 1 mole of water weighs 18.2 grams, right? We did that in the last homework. Then what if we had 25 grams of water? How many moles is this? To figure it out, let's go back to the dozen analogy. If we know that 1 dozen donuts is 100 grams, right? We figured out the gram molar mass of a donut. Fantastic, 100 grams. How many dozens would we have if we had 500 grams of donuts? Okay, 500 grams, 1 dozen is 100 grams. We'd have 5 dozen, right? Did you do it in your head? You probably took the 500 grams and divided it by 100 grams to get 5 dozen, right? You took 500 grams divided by 100 grams per dozen to get 5 dozen, right? The grams on the top and the bottom, they cancel out. You just have dozens left. We can do the same calculation with moles instead of dozens. So if 1 mole of water is 18.2 grams, right? We figured that out in the last homework. How many moles are there in 25 grams of water? So just like before, we take that total mass, right? 500 grams before. Now we take the 25 grams and divide it by the gram molar mass, right? This was the dozen mass, the 1 dozen mass, but here we have the 1 mole mass. 1 mole of water is 18.02 grams. So we take 25 divided by 18.02. 25 divided by 18.02, and we get 1.387. I'm going to round this up to 1.4 moles. 1.4 moles. Let's see if this makes sense. If 1 mole is 18, if we have 25, it's about 1.5 moles, a little bit less than 1.5. So this number makes sense. The thing you have to realize is that because each substance has a different gram molar mass, right? This is just for water. The calculation is a little different every time, right? We have to think about the atoms of every substance that are different sizes and different combinations. So we have to know this number to be able to do this calculation. Let's try a second example. If we have 500 grams of propane, C3H8, how many moles is this? So remember, we have to know the gram molar mass of propane. We've done this before. The gram molar mass, we had 3 C's and 8 H's, 3 times, oh yeah, we got to use our periodic tables again. Yay! Back to the resource library, periodic table. Carbon was 12.01. So 3 times 12.01 equals 3 times 12.01 equals 36.03, 36.03, and H, there were 8 of them, times hydrogen is 1.01, 1.01 equals 8.08, and then we added these two things together, right? 36.03 plus 8.08 to get 8.08, 44.11. 44.11 grams is equal to 1 mole. Okay, we had to do that first. Now we're going to take this 550 grams, and divide it by 44.11 grams per mole. Equals, all right, let's figure out where we get 550 divided by 44.11, and we get 12.46. I'm going to round that to 12.5 moles. Does this make sense? If 1 mole is 44 grams, it's a little bit more than 10 times, right? 10 times would have been 440 grams. So it makes sense that we get 12.5 moles of propane. 12.5 moles of propane. Great. But now let's combine this new skill with what we know about moles and counting. 1 mole of things is 6.02 times 10 to the 23rd things, right? It's just like 1 dozen things is equal to 12 things. So if we have 3 dozen donuts, how many donuts is that? 36, right? How'd you do it in your head? Well, you probably took a dozen, 12, and multiplied it by 3, right? Because 12 times 3 is 36. Now let's translate it to moles. When we're talking about chemical substances, we usually call these things particles, and particles can mean atoms or molecules. So if we have 3 moles, how many particles is that? Just like the dozen, right? If a dozen is 12, we take that dozen number times 3, but 1 mole doesn't equal 12. 1 mole equals 6.02 times 10 to the 23rd particles. So we're going to multiply this big number by 3. Let's do that. We can take 6.02 times 10 to the 23rd particles times 3 equals, let's use our calculator. 6.02. Now we're going to use the exponent key to give us our times 10 to the. This is what it looks like in our calculator. 6.02 times 10 to the 23rd times 3 equals 1.8. This is how the calculator is writing our exponent. So this is what number our calculator spits out, but we're going to translate this into scientific notation. 1.8 times 10 to the 24th. Remember, we want to put this as our exponent. You do format, text, superscript. 1.8 times 10 to the 24th particles. And that's our answer. That means that 3 moles is 1.8 times 10 to the 24th particles. What if it's not that nice round number like 3? What if it's that 12.5 moles of propane? How many particles of propane is that? Let's find out. Okay, so the 12.5 moles. How many particles are in 12.5 moles? Well, we take again that we have 6.02 times 10 to the 23rd particles per mole times 12.5 moles. So let's put this into our calculator. Remember, the 23rd is up top. So 6.02 times 10, right? That's the exponent, 10 to the 23rd, and then times 12.5 moles equals 7.5 times 10 to the 24th. Copy this, 7.5 times 10 to the 24th particles. So that means that 12.5 moles of propane equals 7.5 times 10 to the 24th particles of propane. All right, and that's my answer. Something to remember is that this E here means exponent. Written by hand, it's 10 raised to the power of something, like 10 to the 24th. It might look like EXP on your calculator if you're using this online one, the EXP there. It might be the EE key, or it might be a key that looks like this. You have to know your calculator. Whew.